Hello, everyone. My name is Megan Mako. Welcome back. If this is your first time, thanks for coming to eCOTS 2020. Today we have Dr. Ruth Hummel from JMP. She is an academic ambassador with JMP, a division of SAS, supporting the technical needs of professors and instructors who use JMP for teaching and research. Dr. Hummel is a co-author of Business Statistics and Analytics in Practice, 9th edition, and has been teaching and consulting about statistics and analytics for over a decade at the University of Florida, at the U.S. Environmental Protection Agency, and now at SAS JMP. She has a Ph.D. in statistics from Penn State University. She is here to talk to us about teaching statistics, intuitive, visual, and fun with JMP. Take it away, Ruth.
Thank you so much, Megan. I am sharing my screen now. And I'm really happy to be here. This is one of my favorite conferences because it's folks who are super engaged in really helping students understand the concepts and teach well. And I think JMP is a great tool for that. I'm going to show you a bunch of things in JMP today that I think are really helpful for teaching, but I'm guessing that many of you who are on are already JMP users. So I'll try to give some tips for folks who are already JMP users about things you might not know exist in the software or extra resources. And if you're brand new to JMP, hopefully I'll show you some things that will be really interesting to you. So I'm going to really focus on showing you just visual and interactive features in the software. So stuff you can do with JMP that helps students really understand their data sets and really get engaged and involved in sort of exploring their data sets. I'm also going to, at the very end, make sure that you know how you can get access to JMP. A lot of universities have licenses where you'd already have access to that. So I'll point some of that information out to you and give you some email addresses or places to go to find more information. But I'm going to spend most of this time just showing you things in JMP. And specifically, I'm going to really focus on some of those very important visual and interactive features that help students explore a data set. So I'm just going to pull open a data set right now, this students data set. So this data set is a data set that I've manipulated a little bit. It's got some cool features in it right away that you can see, like you can have pictures as an element. So I have a column in this data set called picture that's got little pictures. I could expand these a little bit, they'll get a little bit bigger. So if you have photos or other image kind of data, you can actually bring that in, and I'll show you in a little bit how you could use it as markers in plots and things like that. So that's a kind of cool extra feature, but that's not the point that I want to show you. A lot of the things that you can do with JMP are things that you would really ideally want to be able to do intuitively as you're searching through data. So you'd want when you're looking at a histogram, for example. So if we go to Analyze and Distribution and we look at a histogram of some of these variables, so maybe age and the sex of the students, maybe their heights, maybe I have some fitness variables like their oxygen uptake and how fast they can run a mile. So if we wanted to explore some of this data in distributions, if I see like outliers, for example, in this outlier box plot for oxygen uptake, one of the things students want to know right away are, who are these outliers? What else can we find out about these outliers? So one thing I can do is hover over a point, and I can see that this student is Leslie, and she had an especially high oxygen uptake variable. And I see her picture also if I chose that as a label feature. And then the second point right below is Carol, and she also has an oxygen uptake of 60. If I grab these 2 points, I can now see these points highlighted in all the other plots. And this is called the dynamic linking in JMP. So this is a really cool feature that helps students really dig down and understand their data better. So I can see right away these 2 students, Leslie and Carol, are both 14 years old. They're both female. They have slightly higher heights, but kind of average heights. They have really fast run times. And if I scroll over, did we put any other variables? No, we didn't. So easy for me to quickly check. So if I saw outliers here, maybe I'm curious if any of the outliers in the other distributions are the same, and I can see really quickly, nope, these 2 points were not this outlier or this outlier. So who is this one with the really slow runtime? If I hover over this, this is James, and he's 14 years old. If I select this point, now I can see James in all the other distributions. So he has the highest runtime and the worst oxygen uptake, and he's kind of average height, he's male, and he's only 12 years old. So really easy for me to dig down and explore things with the data. I can also look at an entire group, like the entire group of males, and see their distribution across the ages, across the heights, across oxygen uptake, across the runtime, or same thing for females instead. Or I could choose just one bar from the age distribution, so just the 13-year-olds, and look at their distribution. So this dynamic linking is the first thing that I want to point out. It makes it really easy for you to dig down and really connect with the data. The next thing I want to show you is in the graph builder. So first thing I always take the students through is distribution. You just want to understand the distributions. That platform is awesome. It was analyze and distribution, but there's also in JMP 15 the ability to just see the distributions in the top of the plot with this new little tiny distribution picture. You just click on this at the top of the data set, and now I can also have that same dynamic linking. You can see as I'm clicking around, it's selecting the data in the data table and across all of these little distributions. Let me move this over and expand this so we can see more of this. So same information that I saw from the main distribution platform, I see sort of summarized here. Graph Builder is the next place I like students to go. It's just this nice drag and drop platform where you can explore data. So you can see a ribbon along the top with lots of different types of graphs that you might want to create. So we can choose from these elements as we drag and drop variables down here. And each of these elements will have extra things we can do in this side panel over here. So I might start by looking at, let's maybe predict the runtime by the height of the students. Let's see if being taller makes you faster. So I see the scatter plot of the data and a smoothed line by default show up. So the first two elements of this ribbon are the things that come by default. If I decide I don't want the smooth line and I just want the points just to kind of look at them without extra hints, I can click that element to take it back off. Or if I want to bring multiple elements on, like the actual best fit line, I can drag more elements on top. But right now, let's just look at the scatter plot. Students have a tendency to overfit with their eyes. So a student first exploring data without a lot of understanding yet might think that there's some kind of a curvy shape here. And we could use the smoother to really explore those curves. The smoother has a lambda that lets you get really overfitting to the data or all the way out to a best fit line. So you can help talk to students about what is overfitting, what is too much curvature that's just too influenced by the points versus what is maybe the real trend that's happening. And then for the real trend, if we are trying to fit a linear trend, we can actually fit the linear trend. And then over here in this line of fit, we could put things like, let's put the F-test on and see if this line, if the slope of this line is significantly different than 0. So is there an actual steepness to it, or is it just flat? And our p-value is not statistically significant, so we don't have evidence that this line is different than just flat. And we could also print the equation here. So this equation is that the y, the runtime, equals 11.92 minus 0.02 times the height. So every time I increase height by 1, I'm going to decrease the runtime by basically 0, but 0.02. And that's, we can see that slope is really flat. I could also explore other variables, not just the height. What if we looked at the oxygen uptake as a predictor of runtime instead? So if I drop oxygen uptake on top of where the height was, now I get a statistically significant p-value for that slope. So this is telling us we have very strong, are incredibly useful. They're useful here in the graph builder, but they're also useful when you're fitting bigger models or you're back in the analysis kind of platforms and you're not just fitting a quick regression line. I could put multiple filters by clicking the AND button. So I could choose, for example, sex here, and I could have just the females who are 15, 16, and 17, so that's aligned with those guys, or just the males who are 15, 16, and 17, or I could reverse the ages, and so on. So if I go back to another platform from the Analyze, Fit Y by X is another platform that lets me have a Y and an X variable, and I could fit different types of relationships between them, or Fit Model lets me have multiple X's or multiple Y's. So if I go into Fit Model and I predict the runtime by, for example, I think we were using the oxygen uptake. So that's the X variable, it's a model effect, and then the runtime is my Y. This lets me fit really complicated models if I want to, including things that are crossed or nested. So I could put the sex effect into this model, and I could even cross the sex effects with oxygen effect. So now I could fit a model that has two different lines, one for the males and one for the females, that allows both the slopes and intercepts to change. So if I click run, then I see those two different lines. This is where I think those markers are getting a little bit busy. So let's go back to the data table, right click, take off the use for marker, so it's just the points again. And here I see those two different lines that were fit, and I see that the oxygen uptake was very statistically significant. The interaction was borderline statistically significant. So there's a little bit of evidence, but not strong evidence, for oxygen by sex to be a different slope, but the oxygen effect is definitely statistically significant with high evidence here. So I see the standard kinds of output: residual by predicted plot, R-squared, the typical things that we want students to see. But I also have this really cool tool called the profiler. So if I look for the word profile, I see factor profiling and profiler. This lets me see, okay, here's the effect of oxygen when I'm holding this steady. So as I stay within the females, here's the effect of oxygen, and I see those predicted run times with the mean confidence interval on it. If I switch to males, you can see that the slope changed. So for females, it's a little bit flatter. For males, it's a little bit steeper. And is that difference in slope statistically significant? That's where that oxygen by sex interaction with that non-significant p-value, that 0.09, that's where that tells us if those slopes being different is statistically significant. So just so many ways of looking at this visually. We can also ask for a local data filter on any analysis. So if I ask for a local data filter here, I could filter it, for example, by age, and I could just look at the 14 through 17-year-olds. So now I've updated all of the model information, all of the p-values are updated for the new subset that I'm looking at, and I can just do this on the fly really easily. Okay, so we talked briefly about the dynamic linking of data, data filtering. We looked at the drag and drop in the graph builder. We looked at profilers. There's also a bunch of built-in concept applets. So if you're just using JMP for data analysis, that's awesome. But there's a lot of teaching tools built in as well. So if you look in the help menu, you'll find a bunch of extra resources. In the help menu, you'll find things like tutorials. So if you've got students who are brand new to using statistical software, they can walk through these tutorials that give them little stories to follow along and really help them learn both how to use JMP and also what the statistical meaning of things is. You can look at the tip of the day to get a little bit more savvy about using JMP. You can look at the statistics index or the scripting index if you want to just look up how do I do something in JMP or how do I script something with the background scripting language. You can also go to this sample data, and this is where I want to direct your attention right now, which gives you a way to get to the sample data directory with over 500 sample data sets that you could use in your course. But it also shows you sort of by analysis type. If you want to teach stuff about regression, there's some really nice data sets in here, like the Anscombe. Here we can look at all these pairs of Y's and X's. So Y1 and X1, Y3 and X3, Y2 and X2, Y4 and X4. Explore the output and see that the R-squareds are all 0.666 approximately. The all of the fit statistics, all of the intercepts and slopes, everything about these looks identical. But if you show the points, you can see this is a nicely fitting graph. Show the points here, you can see that there's one point that has an extra effect. If we show the points here, we can see this is actually a quadratic. If we show the points here, we can see that this is, again, one point is influencing this entire line. So lots of really nice data sets that show good example things, and there's usually little hints in the top that tell you sort of what we think that this is really good to show. So you can certainly find data sets according to the type of methodology that you want to teach, but you can also find all these really cool teaching resources here. So under, for example, the teaching scripts, the interactive teaching modules, if you want to teach about, for example, sampling distribution. So if I choose sampling distribution for the sample mean, the top panel shows us the population, and maybe I'll choose to show it as a histogram and with the curve over it. The middle panel shows the one sample that's been drawn, and the bottom panel shows the distribution of the sample mean, so the sampling distribution of the mean. So if this was, for example, IQ, and I could change any of this with a mean of 100 and a population standard deviation of 15, if I wanted to draw a sample of, say, size 30, I'll just draw one. I'm going to click the animate illustration just as we draw more samples, it'll be easier to see them. And I'll say draw samples. So our sampling distribution is just one value to begin with. Here's the sample itself. That's its mean. Right now, there is no standard deviation for the sample means because we only have one. No way to calculate a standard deviation, but when we draw a second one, now we get a standard deviation down here. So we're starting to build the sampling distribution. This is just our second sample. I could draw another one. There's our third sample. Now we have 3 values down here. Draw another one. I could draw 100 more. And so animating it lets me see it as it updates. And so I start seeing a normal distribution that's much tighter forming down here. So if I compare that to the population, they should be centered around the same place, but now I'm building a distribution that's much tighter. So lots of tools like this. Demonstrate regression is another really good, it lets you can create your own if you wanted to save this sample to a data table. You could actually make an example that you like by clicking points in here, and then you can choose this red triangle and say save sample to data table, and now I've got the Y and the X values for that little sample. This is awesome if you want to build examples to demonstrate something. This demonstrate regression is really cool for that. You can change what the intercept is, moving the points up and down. You can change the slope to make it steeper or negative. You can change the correlation of the points to get different simulations. And then from this sample data, you can fit the least squares line. You can fit the squares to it. So that's the residuals. I can show the actual squares that are added up to make that sum of squares, and so on. So there's a lot of really cool things here. There are some videos on our website and some helpful one-page guides to sort of walk you through how to use these. There are lots more of these as well. So the interactive teaching modules are really cool, but there's also some teaching demonstrations, some calculators, more simulations. So all the things here down in the teaching resources, really useful. If you're not taking advantage of these, there's some really nice teaching tools here. And then if in your curriculum you are also introducing beyond just maybe ANOVA and regression types of concepts, if you're moving into a little bit of data science, even possibly before ANOVA and regression, if you just want to help students understand sort of decision trees or things of that nature, those tools are built right into JMP. And I'm going to close a few things. So if, for example, I wanted to predict oxygen uptake by some of these other variables, I could go to here to analyze. So we saw distribution. Fit Y by X is a nice tool for 1X, 1Y. Fit model is good for more X's and more Y's. Predictive modeling has lots of tools for lots of different kinds of predictive models. So if you wanted to use a simple partition with your students to introduce some simple data science early in the curriculum, that's this platform here. And as we introduce data science, we typically need to start teaching our students that you need to have some training data to build your model on, and then data to test it on, holdout data to actually see if you're doing a good job. So a different concept than a lot of our statistical inference models. Instead, we really want to just do a great job of predicting. How do we know if we're doing a great job of predicting? Well, we need a data set to test it on. So there's a nice tool here called Make Validation Column. I just click OK once, I click Go once, and it really quickly makes me a validation column with some of the rows assigned to the training and some to the validation. So now when I go back to that partition, I can use this validation column to hold training to build the model and to use that validation set to test the model on. So it's really easy to set this concept up for students. So here, if I wanted to predict, for example, the runtime by some of these other variables like sex and age, maybe their height, maybe their oxygen uptake, we could put lots of things in here if we wanted to. I'll say okay, and we can make one split at a time. In this case, we're making a regression tree where we're trying to separate the rows so that we can split out the the runtime as much as possible. So this group that has oxygen uptake less than 45.31, they have really long run times for their mile. This group that has high oxygen uptake, so really good cardiovascular fitness, this group has faster run times. So if we click split again, now we see the next split is another oxygen uptake split. We split again. We can click the go button, and the go will actually help us see how many splits make the most sense in order to do the best we can on our final data set. So that's a bunch of different options for how we can transition easily into some data science within JMP. Again, that profiler is available here. So we have the profiler, which shows us the idea that we've basically got a step function happening here. So age never came into the model, sex never came into the model, height never came into the model. The only thing that actually mattered in this model was oxygen uptake, and it gave us 2 different splits. So we ended up with 3 different values that are important. So if your oxygen uptake was the lowest group, your average runtime was 12-minute miles. If you were in the middle oxygen uptake group, your average runtime was 10.5-minute miles. And if you were in the lowest oxygen uptake group, your average runtime was just a little bit more than 9-minute miles. So it's easy to understand with this profiler, none of these variables mattered at all. The only thing that ended up mattering in this tree was oxygen uptake, and we can see how those different leaves are predicting the different runtimes. Okay, a few final things I want to show you. So again, all that dynamic linking is really helpful for students to dig into their data sets. The graph builder is a really nice tool, and the transition to data science, especially with partitioning, is really helpful right within JMP. If you are not currently using JMP and don't know how to get access to it, there's a very good chance that your university already has a JMP license. So most universities in the United States, a lot of universities around the world have JMP licenses in place. So the first recommendation is to go to your software page for your university and see if you see JMP listed. If you don't see it listed there, you are welcome to send us an email at academic@jmp.com and let us know, sorry, I just advanced that. Let us know that you're hoping to have a license at your university. You'd like to know if you do already, you couldn't find evidence. We can find out for you if you have a license and who that contact person is, or we can help you find out how to get a license at your university. Academic licenses for JMP are very inexpensive. You can go to our software licensing page to see those prices and understand more about that licensing structure. You also can get licenses for your students apart from a campus license. We recommend the campus license because it comes with JMP Pro, which has every feature in JMP. So JMP Pro is the fullest featured version of JMP, but there are 2 other versions as well. There's a middle version that we just called JMP, and students can get that version from onthehub.com/JMP for a small fee. I think it's $30 for a 6-month license or $50 for a 12-month license. So students can purchase it themselves for classroom use and not-for-profit home use. JMP Student Edition is also another version that doesn't have as many features as JMP Pro, and it has slightly different features than standard JMP. And that comes bundled with a lot of textbooks. So there's a good chance the textbook you're using for an intro stats class can be bundled with JMP Student Edition. So if your university does not have a license, this is another really easy way to get the software for free or super low cost for your students. Students can also buy that Student Edition for $20 for a 3-year license. So super inexpensive. We hope that it's easy for you and your students to get access to JMP. If you have any questions about that, email us at academic@jmp.com. And then,
if I can interrupt just for a second, clarification on that. So does the academic access provide access to students or just faculty staff?
the academic suite, if a university buys the license, it is for all students, all faculty, everyone doing teaching and academic research at that university. So that license would be for students to get access and for faculty to get access.
Thank you.
You're welcome. And again, send us an email at academic@jmp.com if you've got more questions on this. A few resources if you're newish to JMP and you just want to learn how to use it a little more efficiently. JMP.com/learn has these great just 1-page guides. So if you need to know how do I make a box plot, we have a page that shows you how to make a box plot. If you want to know how do I do randomization testing, there's a page that tells you how to do that. And most of these pages also have a corresponding 2 to 3 minute video. So you can click on the video or send that to your students, send them to that URL if you prefer them to access it that way. I'm putting a couple links to some blogs about our teaching resources. So this one, Shifting to Online Instruction, and this one about the bread and butter when teaching with JMP, that are just kind of overviews of our resources. So this will be in the slides, which you can access later after this presentation. So I'll pause now. I think we've got a couple more minutes if there are any other questions.
Yes, we have just about 2 minutes. The Graph Builder tool is really great, and the participant asks, I know there's a way to put data on a map demoed by Dick DeVoe at the last eCOTS. Could you quickly mention how this is done?
Yes, absolutely. So there's 2 easy mapping ways to map. One is aggregate maps, where you want the shape and filled in by a color because of maybe population density or something. The other one is locations, pinpoint locations. I will show you really quickly. There's a data set called US demographics. Let me find that one. So this is all these sample data sets that you could be accessing in the software to teach with if you want to. And actually this one will work. SAT by year, I think has, yeah, so it has the states of the United States. I'm going to turn off these color points by clearing the row states so that that doesn't make the map look colored to begin with. We go to Graph, we go to Graph Builder, and we've got this state name. We just drag it into this map shape, and it builds the map for us as long as you've got US states or county FIPS codes or world countries. We have built-in map shape files for that already. And so then we could color it by, for example, the expenditure in 1997 on education. Or we could flip through many different variables here. So you can make maps like this that I would call an aggregate map, where each state is a shape and you're filling it in with a color from some other variable, or you can do maps where you've got pinpoint locations. There's a sample data set called San Francisco Crime. That's a nice example of that. I won't show that now, but you can look that up. If you look up JMP San Francisco Crime, you'll probably be able to find a video on that.
This is a wonderful tool, the Graph Builder, and being able to make the maps, that's just wonderful. Unfortunately, we are out of time. Those who want to continue the conversation can continue it using Slack, Twitter, or on Facebook.